Desde que o ser humano olhou para as estrelas pela primeira vez, uma pergunta nunca saiu da nossa mente: estamos sozinhos no universo? Neste exato momento, existem bilhões de planetas orbitando outras estrelas, e muitos deles poderiam ter as condições certas para a vida. Mas vida alienígena não é apenas sobre pequenos homens verdes em discos voadores. Estamos falando de bactérias em oceanos congelados, criaturas flutuando nas nuvens de planetas gigantes e talvez até civilizações avançadas tentando nos encontrar do mesmo jeito que procuramos por elas. A verdade é que a vida pode existir em lugares que nunca imaginamos, usando química completamente diferente da nossa. E os cientistas estão descobrindo novos sinais e possibilidades a cada dia. Será que já recebemos mensagens alienígenas sem perceber? Poderiam existir formas de vida tão diferentes que nem reconheceríamos como vida? E se a resposta para nossa solidão cósmica estiver mais perto do que pensamos? Se inscreva no canal, deixe seu like e comente de que parte do mundo você está assistindo, se acomode e relaxe, vamos começar. Tonight, we are going to talk about something that has lived in the human mind for as long as there have been humans looking upward. É uma questão que parece impossivelmente grande e estranhamente íntima. Are we alone? Not alone in our homes or our cities or even on our planet, but alone in the vast darkness that stretches beyond our atmosphere, beyond our solar system, além de tudo o que podemos ver, mesmo com os nossos instrumentos mais poderosos. Are we the only ones looking up and wondering, or is someone somewhere looking back? This is not a question we can answer tonight. Perhaps it is not a question we will answer in our lifetimes, but we can explore it. We can turn it over slowly, examine it from different angles, and let it carry us gently through the night. Because the search for alien life is not just about finding others, é também sobre compreender a nós mesmos, nosso planeta, e o fato estranho e improvável de que estamos aqui, perguntando essas questões para o silêncio. Before we begin, I would like to know where you are right now. What time is it where you are listening? Are you lying down, the lights dimmed, the day finally releasing its hold on you? Or perhaps you are sitting quietly, the world around you settling into its evening rhythm. Wherever you are, whatever hour it is, I am glad you are here. Se este tipo de questionar, esta lenta exploração do desconhecido, é algo que você encontra reconfortante, eu ficaria grato se você considerasse subscribing or leaving a like. It helps this small voice reach other curious minds across the darkness. Mas não há pressão. Just an invitation, like the faint signal we send into space, hoping someone might hear. So let us begin. Let us step outside on a clear night and look up. Acima de nós, se o céu estiver escuro o suficiente, podemos ver milhares de estrelas. Each one is a sun, many of them larger and older than our own. And around many of those stars, we now know there are planets, worlds of rock and gas and ice, spinning silently in the void. Alguns são queimados por suas estrelas, suas superfícies fundidas e sem vida. Outros estão congelados, trancados em inverno permanente longe de qualquer calor. But some, a precious few, orbit at just the right distance. Não muito quente, não muito frio. We call this the habitable zone, though that name carries assumptions we will need to examine later. Quando olhamos para aquelas estrelas, estamos olhando para possibilidades. Cada ponto de luz poderia ser um sol com planetas. E cada planeta poderia, em teoria, abrigar algo que estamos procurando desde que compreendemos que as estrelas não são apenas luzes no céu sky, but distant suns like our own, life. The word itself is simple, but what it means is far more complicated than it first appears. We think we know what life is because we are surrounded by it. Trees and birds and insects and bacteria, all of them alive in ways we recognize. But when we step back and try to define life in a way that would apply anywhere in the universe, the edges of the concept start to blur. Is life anything that reproduces, anything that responds to its environment, anything that maintains itself against the pull of entropy, building order out of chaos? Crystals crescem e replicam seus padrões, mas nós não as chamamos de vivas. Fire consumes and spreads and responds to wind and fuel, but it is not life. Viruses reproduce, but only by hijacking the machinery of cells, and scientists still debate whether they truly qualify as living. So what is life, really? And if we do not fully understand it here on the one planet where we know it exists, how will we recognize it out there, in forms that might be nada como qualquer coisa que já vimos? This is where our journey must begin, not with the discovery of alien life, but with the question itself. Because the search for life beyond Earth is as much a search for understanding as it is a search for contact. Every time we refine our definition of life, every time we discover an organism thriving in conditions we thought were impossible, we expand the boundaries of where and how we might find others. And every time we send a signal into space or point a telescope at a distant world, we are reaching across the darkness with a simple message. Estamos aqui. Você? O universo é incrivelmente vasto. Our sun is one of perhaps 400 billion stars in our galaxy alone. And our galaxy, the Milky Way, is just one of perhaps 2 trillion galaxies in the observable universe. The numbers become meaningless very quickly, too large for our minds to hold, but the implication is clear. If even a tiny fraction of those stars have planets, and even a tinier fraction of those planets have the right conditions, there should be billions, possivelmente trilhões, de mundos onde a vida poderia existir. The question is not whether the universe could support life. The question is whether it does. E se fizer, a próxima pergunta segue imediatamente. Qual é o tipo de vida? Quando a maioria das pessoas imagina alienígenas, elas imaginam algo aproximadamente como nós. 2 olhos, uma boca, braços e pernas, andando ereto, usando ferramentas, falando línguas, construindo cidades. This is the legacy of science fiction, and it is not entirely unreasonable. Evolution on Earth has converged on certain solutions multiple times. Eyes have evolved independently dozens of times because light is a useful thing to detect. Flight has evolved separately in insects, birds, bats, and even some fish. Intelligence, in various forms, has appeared in dolphins, octopuses, crows, and primates. So perhaps intelligence and tool use and even language are common solutions to common problems, and perhaps alien life would resemble us in some fundamental ways. Mas talvez não. Talvez a vida em outro lugar tenha seguido caminho completamente diferente. Perhaps it never crawled out of the oceans, never developed eyes, never built bodies at all. Perhaps it exists as vast fungal networks spreading through the soil of a distant world, thinking slow thoughts over centuries. Perhaps it floats in the atmospheres of gas giants, feeding on lightning and complex chemistry, never touching solid ground because there is no solid ground to touch. Perhaps it is so small we would mistake it for a chemical process, or so large we would mistake it for a geological feature. Perhaps it does not think in any way we would recognize as thinking. Perhaps it has no awareness of itself or of us, and yet it lives and grows and continues year after year under a sky we will never see. This is the humbling truth at the heart of the search for alien life. We are looking for something we might not recognize even if we found it. Our entire understanding of biology, of chemistry, of what it means to be alive, is based on a sample size of one. Planeta, uma árvore da vida, exemplo. É como se tivéssemos visto apenas tipo de pássaro e estivéssemos tentando imaginar como outros pássaros poderiam parecer. We might guess at different colors, different sizes, different songs, but would we imagine a penguin, beija-flor, avestruz? Would we imagine something that does not fly at all, or something that spends most of its life underwater? Or something that migrates thousands of miles guiados por campos magnéticos que não podemos perceber. This is why the search is so difficult. We are not just looking for life. We are looking for something that might not leave the kind of traces we know how to find. We are listening for signals that might not sound like signals. We are trying to imagine the unimaginable, using tools built from the only example we have, e ainda procuramos, because the possibility, however remote, is too profound to ignore. Se encontrássemos até a vida mais simples em outro lugar, até único bactéria no solo de Marte ou micróbio nos oceanos de Europa, isso mudaria tudo. It would mean that life is not a miracle that happened once, but a process that happens wherever conditions allow. Significaria que o universo não é vazio, mas fértil, and it would mean that we, for all our loneliness, are part of something much larger. But we are getting ahead of ourselves. Before we can talk about finding life elsewhere, we need to understand what we are looking for. We need to go back to the beginning, to the basic chemistry and physics that makes life possible, at least as we know it. We need to ask what life needs, what it does, and whether those needs and processes could be met in ways we have not yet imagined. Because the story of alien life begins not with spaceships or radio signals, but with the strange and beautiful chemistry that allows matter to organize itself, to remember, and to grow. That is where we will go next, into the fundamental nature of life itself, to see what it is made of and whether the recipe could be written differently elsewhere. So rest for a moment. Deixe sua respiração lenta. Feel the weight of your body against the surface beneath you. Acima de você, se você pode vê-los ou não, as estrelas estão girando. And around those stars, worlds are spinning. Alguns estão mortos, alguns são estranhos além de nossa imaginação, e alguns talvez estão vivos. We will explore them together, one thought at a time, as the night deepens and the universe continues its vast, silent rotation. Não há pressa. Nós temos todo o tempo que precisamos. The search for alien life has been going on for decades, and it will continue long after we are gone. Tonight, we are simply joining that search, adding our voices to the question that has echoed through human history. Are we alone? Vamos encontrar juntos. When we try to define life, we usually start with a list. Life grows, reproduz, responde ao seu ambiente, mantém-se a si mesmo, reparando danos e resistindo à degradação, evolui ao longo do tempo, adaptando-se a novos desafios. These are the characteristics we see in every living thing on Earth, from bacteria to blue whales. But even this simple list starts to break down when we look closely. A mule cannot reproduce, yet it is alive. Trabalhador abelha nunca terá descendentes, mas vive. A virus cannot maintain itself without a host, yet it seems to exist in that strange space between life and non-life. Not quite either, not quite neither. This is the first problem we face when searching for alien life. We cannot even agree on what life is here at home. How can we hope to recognize it in a form we have never encountered? The answer, perhaps, is that we need to think less about what life is and more about what life does. Life, at its core, is a process. It is matter organizing itself in ways that resist the natural tendency toward disorder. The universe, left to itself, moves toward entropy, toward randomness, toward heat, death, and equilibrium. Mas a vida empurra para trás, constrói estrutura, it stores information, it creates order out of chaos, at least temporarily, at least locally, using energy from its environment. On Earth, all life is built from the same basic components. Carbon atoms form the backbone of every biological molecule, linking together into long chains and complex shapes. Water acts as the solvent, the medium in which the chemistry of life takes place. Proteins do the work, catalyzing reactions and building structures. DNA stores the information, the instructions for building more life. This system is universal on our planet. Every living thing, from the simplest bacterium to the most complex animal, uses the same genetic code, the same basic molecular machinery. Nós somos todas variações sobre único tema. But is this the only theme possible? Carbon is uniquely good at forming complex molecules because of the way its atoms bond. It can connect to 4 other atoms at once, creating branching structures of almost infinite variety. Silicon, which sits just below carbon on the periodic table, can also form 4 bonds. Could silicon-based life exist on a world where carbon is scarce and silicon abundant? Perhaps, though silicon bonds are weaker and less flexible. Silicon-based molecules tend to be more brittle, less capable of the dynamic folding and unfolding that carbon-based life depends on. But perhaps on a colder world, where molecules move more slowly, silicon could work. Perhaps there are forms of life built on chemistry we have not even considered. Water, too, seems essential to life as we know it, but it might not be the only option. Water is an excellent solvent, able to dissolve more substances than almost any other liquid. It stays liquid over a wide range of temperatures, at least under Earth-like pressure. E seu imóvel de expandir quando congela significa que a gelo flutua, isolando a água líquida abaixo e permitindo que a vida sobreviva em mares congelados. But on a colder world, perhaps ammonia or methane could serve the same purpose. Essas substâncias são líquidas a temperaturas muito mais baixas do que a água. On a moon like Titan, where the surface is far below freezing and lakes of liquid methane dot the landscape, could there be life swimming in those alien seas using chemistry we would not recognize? This brings us to one of the most profound questions in astrobiology. Is all life in the universe like us, built from carbon and water and DNA variations on the same basic theme? Or did life arise independently in many places, each time finding different solutions to the same problems, building bodies and metabolisms from qualquer material que estivesse disponível? Se tudo vivo no universo compartilha nossa química básica, isso poderia sugerir que a vida começou em um lugar e se espalhou, transportada em meteoritos ou comets, or even deliberate missions, seeding world after world with the same molecular machinery. But if life can arise from many different chemistries, if it is a general property of matter under the right conditions, then the universe might be far stranger and more diverse than we imagine. Não sabemos a resposta. We cannot know not yet, because we have only one example. Terra é o único planeta onde sabemos que existe vida. We are studying a sample size of one and trying to extrapolate to the entire universe. É como tentar entender toda a música possível por ouvir uma única canção. We can analyze that song, break it down into notes and rhythms and harmonies, but we cannot know what other songs might sound like, what other instruments might be used, what other scales and structures might be possible. We need more examples. We need to find life elsewhere, even if it is just a microbe, even if it is nothing like us. Because only then will we begin to understand whether life is a specific chemical accident or a general principle of nature. But even as we acknowledge this uncertainty, we can still use what we know to guide our search. Life on Earth, whatever its chemistry, requires certain things. Necessita energia para manter-se e crescer. Necessita de matérias-primas para construir suas estruturas. It needs some way to store and transmit information so that successful strategies can be passed on. And it needs a stable enough environment that it can persist over time, adapting and evolving without being wiped out every few generations. These principles might be universal. Any life anywhere, no matter how strange, might need these same basic elements: energy, matter, information, and stability. Energy comes in many forms. On Earth, most life ultimately depends on the sun. Plants and algae capture sunlight and convert it into chemical energy through photosynthesis. Animals eat plants or eat other animals that ate plants, passing that energy through the ecosystem. But not all life on Earth depends on the sun. In the deep ocean, around hydrothermal vents where superheated water spews from cracks in the seafloor, entire ecosystems thrive in total darkness. These organisms draw their energy from the chemicals in the vent water, from the temperature gradient between the hot fluid and the cold ocean, from reações químicas que acontecem quando certos minerais dissolvem. This is called chemosynthesis, and it shows that life does not need sunlight to survive. It just needs energy from somewhere. This discovery has profound implications for the search for alien life. Se vida pode existir na escuridão dos oceanos da Terra, tirando energia da química e calor, então ela pode existir na escuridão dos oceanos de oceanos alienígenas também. Europa, one of Jupiter's moons, is covered in ice, but beneath that ice is an ocean of liquid water, kept warm by the tidal forces that stretch and squeeze the moon as it orbits. That ocean is dark, but it might have hydrothermal vents, just like Earth's deep sea. Could there be life there, clinging to those vents, living in that cold darkness, never knowing the sun exists? Enceladus, a moon of Saturn, also has an underground ocean, and geysers of water vapor erupt from cracks in its icy surface, carrying with them moléculas orgânicas, os blocos de construção da vida. Could those geysers be carrying evidence of alien microbes thrown into space by the moon's internal activity? These are not science fiction fantasies. These are real worlds in our own solar system, places we can reach with our current technology. Eles podem abrigar vida, not intelligent life, probably not even multicellular life, but life nonetheless. Simple organisms adapted to the cold and dark, using chemical energy to survive. If we found such life, it would be the greatest discovery in human history. It would mean that life arose independently at least twice in our solar system, and if it happened twice here, it could happen anywhere. The universe might be full of life, most of it hidden beneath surfaces, in oceans and caves and soils, invisible from space, unknown even to itself. But we are still talking about life as we know it, carbon-based, water-dependent. What about truly alien life? Life so different we might not recognize it at all. Some scientists have speculated about forms of life that do not even require a planet. In the upper atmospheres of gas giants like Jupiter and Saturn, there is a layer where the temperature and pressure are not too different from Earth's surface. Could there be organisms floating in those atmospheres, feeding on sunlight and complex chemistry, reproducing by splitting apart like bacteria, never touching solid ground because there is no solid ground? We have no evidence for this, but we have no evidence against it either. The chemistry of those atmospheres is rich and complex, full of organic molecules, the same carbon-based compounds that are the building blocks of life on Earth. Impossible. Some have even suggested life could exist in forms we would not consider matter at all, at least not matter as we usually think of it. Could there be electromagnetic beings, patterns of energy that maintain themselves and reproduce, living in the magnetic fields of stars or the ionized winds of nebulae? Could there be life on the surfaces of neutron stars, where the gravity is so intense that atomic nuclei are crushed together into strange forms of materia, criando estruturas e padrões que ainda não entendemos? Could there be life that exists only as information, patterns in quantum fields, thinking thoughts at the speed of light? Estas ideias são especulativas, passando à filosofia em vez de ciência, but the universe is strange and we should not assume we know all the forms that life could take. The question of what life is leads naturally to the question of where it could exist. And that is where we will go next, into the vast catalogue of worlds we have discovered beyond our solar system, the exoplanets that orbit other stars. Some are giant and hot, others tiny and cold, and a few, just a precious few, seem to orbit in that narrow zone where liquid water could exist, where life as we know it might have a chance. We will explore those worlds, imagine what they might be like, and ask whether any of them could be home to something alive. But for now, let the idea rest. Life is chemistry, but it might also be more. É informação, mas também processo. É o universo olhando para si mesmo, pensando em si mesmo, se perguntando o que mais há lá fora. E se existir em formas que reconhecemos ou em formas que sequer podemos imaginar, a busca por ele é a busca por nós mesmos, por nosso lugar em cosmos that is far larger and stranger than our ancestors ever dreamed. Nós vivemos em tempo extraordinário. For most of human history, we could only guess at what lay beyond our solar system. We knew the stars were suns, at least we suspected they were, but we had no way to know if they had planets. We could imagine other worlds, and we did, filling them with every kind of creature and civilization our minds could conjure. But we had no data. We could not look and see. Agora podemos. Over the past few decades, astronomers have discovered thousands of planets orbiting other stars, a field of study that barely existed a generation ago. We call these worlds exoplanets, and they have changed everything we thought we knew about planetary systems. The first confirmed exoplanet orbiting a sun-like star was found in 1995. It was nothing like what anyone expected. Instead of a small, rocky world like Earth, it was a gas giant like Jupiter, but it orbited incredibly close to its star, completing a full orbit in just a few days. Foi quente, tidally locked, uma face sempre virada para a estrela, a outra em noite perpétua. It was a hostile place, nothing like anything in our solar system, and its discovery threw all our theories into chaos. How could a giant planet form so close to its star? Como poderia sobreviver lá, naquela queimação? Slowly, astronomers realized that planets could migrate, moving inward or outward over time, shaped by gravitational interactions and the distribuição de gás e poeira no sistema solar primitivo. Our solar system, with its neat arrangement of rocky inner planets and gas giants farther out, was not the default. Foi apenas uma possibilidade entre muitas. Since that first discovery, we have found thousands more. Some are hot Jupiters like that first one, massive worlds orbiting close to their stars. Some are super-Earths, rocky planets larger than our own, with stronger gravity and thicker atmospheres. Some are ice giants, mini-Neptunes, worlds of water and methane and ammonia wrapped in hydrogen and helium. And some are rocky worlds, roughly Earth-sized, orbiting at distances where liquid water could exist. These are the worlds that excite us most, the ones we call potentially habitable. But potencialmente habitável não significa habitado. It just means condições podem ser adequadas. Seja a vida realmente tomou conta é outra questão inteiramente. The problem is that we cannot see these worlds, not directly. They are too far away and too dim compared to the stars they orbit. Imagine trying to see a firefly next to a spotlight from 1,000 kilometers away. That is roughly the challenge. Instead, we detect exoplanets indirectly, using clever techniques that reveal their presence even when we cannot see them. O método mais bem-sucedido é chamado de método transitivo. Quando planeta passa em frente de sua estrela de nosso ponto de vista, ele bloqueia uma fração ínfima da luz da estrela. The star dims just a little for a few hours or days. If we see this dimming happen repeatedly at regular intervals, we know something is orbiting the star, blocking its light each time it passes. By measuring how much the star dims, we can estimate the size of the planet. By measuring how often it happens, we can calculate the length of its orbit and its distance from the star. A outra forma é chamada o método da velocidade radial. A planet does not just orbit its star. The star also orbits the planet, or more precisely, they both orbit their common center of mass. This causes the star to wobble very slightly, moving toward us and away from us as the planet circles. This motion shifts the star's light toward the blue end of the spectrum when it moves toward us and toward the red when it moves away, an effect called the Doppler shift, the same thing that makes an ambulance siren change pitch as it passes. By measuring this shift, we can infer the presence of a planet and estimate its mass. These methods, and others, have given us a vast catalogue of worlds, each one a data point in our growing understanding of how planetary systems form and evolve. But finding a planet is just the first step. What we really want to know is whether any of them could harbour life. For that, we look at several factors. O primeiro e mais óbvio é localização. Is the planet in the habitable zone, the region around its star where temperatures are right for liquid water to exist on the surface? This zone is sometimes called the Goldilocks zone, not too hot, not too cold, but just right. For a star like our Sun, the habitable zone is roughly where Earth orbits. For cooler, dimmer stars, the habitable zone is closer. For hotter, brighter stars, it is farther out. But localização não é tudo. A planet in the habitable zone could still be lifeless if it does not have an atmosphere, or if its atmosphere is too thin or too thick, or if it lacks water to begin with. Venus is technically in the Sun's habitable zone, but it is a hellish world, with surface temperatures hot enough to melt lead and an atmosphere so thick and full of carbon dioxide that the pressure at the surface is 90 times that of Earth. Mars is also in the habitable zone, or at least on its outer edge, but it has lost most of its atmosphere, and its surface is cold and dry, bombarded by radiation. Being in the habitable zone is necessary, but not sufficient. O mundo precisa do tamanho certo, da composição certa, da distância certa do seu astro e da história certa. It needs to have held onto its água e sua atmosfera. It needs to be geologically active, recycling carbon and other elements through volcanism and tectonics, maintaining a stable climate over billions of years. É equilíbrio delicado, e estamos apenas começando a entender como mundos tão raros ou comuns poderiam ser. Some of the most exciting exoplanets we have found are those that seem, at least from a distance, to meet many of these criteria. There is Proxima Centauri b, a rocky planet orbiting the closest star to our Sun, just over 4 light-years away. Está na zona habitável de sua estrela, embora essa estrela seja uma anã vermelha mais fria e fraca que o Sol, e anãs vermelhas são conhecidas por violentas erupções that could strip away a planet's atmosphere. There is the TRAPPIST system, where 7 Earth-sized planets orbit a small, cool star, and 3 of them are in the habitable zone. There is Kepler 452b, a planeta ligeiramente maior que a Terra, orbitando Sol semelhante a uma estrela a uma distância semelhante à órbita da Terra, embora saibamos muito little about its composition or atmosphere. These worlds are tantalizing possibilities, but we do not yet have the tools to study them in detail. We cannot yet analyze their atmospheres, look for water vapor or oxygen or methane, the chemical signatures that might indicate life. Mas que isso está mudando. New telescopes, both in space and on the ground, are being built with the capability to study exoplanet atmospheres. Quando planeta transita em frente de sua estrela, uma pequena quantidade da luz da estrela passa através da atmosfera do planeta antes de chegar a nós. That light carries information absorbed or scattered by the gases in the atmosphere, creating a spectrum, a kind of fingerprint. By analyzing that spectrum, we can determine what the atmosphere is made of. If we find oxygen and methane together, for instance, that could be a sign of life, because these gases react with each other and would not persist in an atmosphere unless something was continually producing them. No planeta que algo é vida. Plants produzem oxigênio e certas bactérias produzem metano. If we saw the same combination on an exoplanet, it would be a strong hint that something similar might be happening there. Of course, we need to be careful. Existem maneiras não biológicas de produzir esses gases. Oxygen can be created by the breakdown of water molecules by ultraviolet light. Methane pode ser produzido por atividade vulcânica. We would need multiple lines of evidence, multiple biosignatures, before we could claim to have found life. Mas a possibilidade é real. Dentro de algumas décadas, podemos ter a resposta. Nós poderíamos apontar um telescópio para um mundo distante, analisar sua atmosfera e encontrar sinais de vida. Or we might find nothing. We might discover that Earth is rare, that the conditions for life are far more delicate than we thought, that we are, in fact, alone, at least in this corner of the galaxy. Qualquer resposta seria profunda. But the search is not limited to exoplanetas. There are worlds in our own solar system, right here within reach, that might also harbour life. We have already mentioned Europa and Enceladus, moons with underground oceans. But there is also Titan, Saturn's largest moon, a world with a thick atmosphere and lakes of liquid methane on its surface. Titan is cold, far too cold for liquid water, but it has weather, seasons, rivers and rain, all made of methane instead of water. Could there be life in those lakes, using methane as a solvent instead of water, built from the same organic molecules that drift down from Titan's atmosphere? It sounds like science fiction, but it is a question scientists are taking seriously. And then there is Mars, our nearest neighbour, a world we have explored with rovers and landers, a world that was once warm and wet, with rivers and lakes, and perhaps even an ocean. Life might have arisen there billions of years ago, when Mars still had a thick atmosphere. E se fosse lá, poderia ainda estar lá, enterrado fundo no subsolo, agarrado à vida em bolsões de água líquida abaixo da superfície congelada. These are the worlds we will explore in more detail next, the places in our solar system where life might exist, hidden in oceans and soils, waiting for us to find it. But before we go there, take a moment to appreciate the scale of what we are discussing. In just a few decades, we have gone from not knowing if any other stars had planets to knowing that nearly every star does. We have gone from imagining alien worlds to cataloguing them, measuring them, beginning to characterize them. We are living in the early days of a revolution in our understanding of the universe. And the next step, the discovery of life beyond Earth, might come in our lifetimes. Pode vir de rover em Marte, cavando na Terra e encontrando micróbio. It might come from a spacecraft flying through the geysers of Enceladus, capturing organic molecules. Or it might come from a telescope analyzing the light from a distant exoplanet and seeing the unmistakable signature of biology. No entanto que venha vai mudar-nos. It will change how we see ourselves and our place in the cosmos. But for now, the question remains open. E a busca continua. The most familiar face in our search for alien life is not a distant star or an exoplanet thousands of light years away. É o pequeno, ferrugem vermelho mundo que compartilha nosso sistema solar, nosso vizinho, Marte. Por mais de século, Marte capturou nossa imaginação. Early astronomers, peering through telescopes, thought they saw canals crisscrossing its surface, evidence of a dying civilization trying to irrigate their arid planet. Those canals turned out to be optical illusions, tricks of the eye and atmosphere, but the dream persisted. If life existed anywhere beyond Earth, surely it would be on Mars. Surely it would be close enough to touch. Mars hoje é deserto frio e seco. Its atmosphere is thin, less than 1% the density of Earth's, made mostly of carbon dioxide. Water, if it exists on the surface at all, is locked in ice at the poles or frozen in the soil. The temperature averages about minus 60 degrees Celsius, though it can rise above freezing during summer days at the equator. Radiation from the sun, no longer filtered by a thick atmosphere or a strong magnetic field, bathes the surface constantly. É lugar hostil, inhospitável à vida como a conhecemos. E porém, Marte nunca foi assim. We know this because we have studied it, sent spacecraft to orbit it, landed rovers on its surface, analyzed its rocks and soil. E a evidência é clara. Bilhões de anos atrás, mais, Marte era mais quente e úmido. It had rivers that carved valleys into its surface. It had lakes that persisted for thousands or even millions of years. It might have had an ocean covering much of its northern hemisphere. This ancient Mars, warm and wet, would have been a very different world, a world where life could have taken hold. We do not know if it did, but the possibility is strong enough that we have spent decades searching. Every mission to Mars carries with it, in some form, the question of life. The Viking landers in the 1970s conducted experiments designed to detect biological activity in the Martian soil. Os resultados foram ambíguos, frustradamente. Some of the tests gave positive results, but they could also be explained by chemical reactions, not biology. We have not yet found definitive evidence of life on Mars, past or present, but we have found evidence that the conditions for life once existed. E que é suficiente para nos manter olhando. The rovers that trundle across the Martian surface today are mobile laboratories equipped with cameras, spectrometers, drills, and chemical analyzers. They study the rocks and soil, looking for organic molecules, the carbon-based compounds that are the building blocks of life. They look for minerals that form in the presence of water, clues to where ancient lakes and rivers once flowed. They look for patterns in the rock layers, signs of sediments deposited by water, places where life might have lived and left fossils. Finding a fossil on Mars would be the ultimate prize, unmistakable evidence that life once existed there. But fossils are rare even on Earth, and on Mars, where the environment has been harsh for billions of years, they might not have survived. So we also look for chemical signatures, traces of biological processes that might still be detectable in the rocks. Dos mais intrigantes desdobramentos em Marte é a detecção de metano na atmosfera. Methane is a simple molecule, one carbon atom bonded to 4 hydrogen atoms. But it is significant because it breaks down quickly under ultraviolet light. If methane is present in the atmosphere, something must be replenishing it. On Earth, most methane is produced by life, by bacteria in wetlands and the guts of animals. On Mars, metano também poderia ser produzido por processos geológicos, reações entre rocha e águas subterrâneas, but it could also be biological. Nós não sabemos ainda. O metano aparece em plumas, concentrado em certas regiões e em certos momentos, então dissipando. This variability suggests localized sources, but we have not yet pinpointed them. Se vida já existiu em Marte, onde poderia ter ido? The surface is too harsh now, but deep underground, things might be different. Nós sabemos que há água gelada sob a superfície marciana, e onde há gelo, pode haver água líquida, mantida do congelamento pelo calor da superfície, planet's interior, or by salts that lower the freezing point. If liquid water exists underground, and if it is in contact with rocks that provide chemical energy, life might survive there, cut off from the surface, living in isolation for billions of years. This is not an outlandish idea. On Earth, we have found ecosystems deep underground, in mines and caves, where organisms live without sunlight, drawing energy from chemical reactions in the rocks. Se puder acontecer aqui, poderia acontecer em Marte. Finding this subsurface life, if it exists, will be difficult. It would require drilling deep into the Martian crust, something we have not yet done. But future missions are planned that might be able to do this, bringing back samples of Martian soil and rock to Earth, where they can be analyzed in laboratórios far mais sofisticados do que qualquer coisa que possamos enviar a Marte. If those samples contain life, even just traces of ancient life, it will answer one of the oldest questions humanity has ever asked. But Marte não é a única possibilidade em nosso sistema solar. There are moons orbiting the giant planets that might be even more promising. Europa, a moon of Jupiter, is slightly smaller than our own moon, but it is entirely different in character. Its surface is covered in ice, smooth and bright, crisscrossed with dark lines and cracks. But beneath that ice, we believe there is an ocean, a global ocean of liquid water, perhaps 100 kilometers deep, containing more water than all of Earth's oceans combined. Este oceano é mantido líquido por aquecimento tidal. As Europa orbits Jupiter, the gravitational pull of the giant planet stretches and squeezes the moon, generating heat through friction in its interior. This heat is enough to keep the water from freezing, despite Europa's great distance from the sun. An ocean, even one hidden beneath kilometers of ice, is a tantalizing place to look for life. On Earth, Wherever we find liquid water, we find life. Os oceanos da Terra estão cheios de organismos, desde a superfície iluminada pelo Sol até as fendas mais profundas. And some of the most interesting life, from the perspective of astrobiology, lives in the deep sea, around hydrothermal vents far from sunlight. These vents spew superheated water rich in minerals and chemicals, and entire ecosystems cluster around them, feeding on the chemical energy. They say Europa's ocean has similar vents, and there is reason to think life could exist there, thriving in the darkness, never knowing the sky exists. We have not yet been able to explore Europa's ocean. The ice is too thick to drill through, at least with current technology, but we can study the moon from orbit, and we can analyze the ice itself. Europa's surface is young, constantly renewed by geological activity that brings fresh ice up from below. This means the surface ice might contain traces of whatever is in the ocean beneath. Future missions plan to land on Europa, analyze the ice, and look for organic molecules or other signs of life. Some missions even plan to fly through the plumes of water vapor that might erupt from cracks in the ice, just as geysers do on Earth, capturing material from the ocean and bringing it back for analysis. Another moon, Enceladus, orbiting Saturn, has already given us a glimpse of what might lie beneath. Enceladus é pequeno, apenas cerca de 500 quilômetros de diâmetro, mas é dos objetos mais brilhantes do Sistema Solar, sua superfície coberta em gelo branco puro. E partir do seu polo sul, geysers erupcionam, disparando plumas de vapor d'água e partículas de gelo centenas de quilômetros para o espaço. The Cassini spacecraft flew through these plumes and analyzed their composition. It found water, of course, but also salt and organic molecules, the building blocks of life. It even found molecular hydrogen, which on Earth is a sign of hydrothermal activity, the kind of activity that could provide energy for life. All the ingredients are there: água, moléculas orgânicas, energia. Se a vida puder existir em Encelado, estaria no oceano abaixo da gelo, alimentado por fontes hidrotermais, assim como em Europa. And then there is Titan, Saturn's largest moon, a world so strange it almost defies description. Titan is the only moon in the solar system with a thick atmosphere, denser than Earth's, made mostly of nitrogen with a trace of methane. The surface is hidden beneath a thick orange haze, but radar and infrared instruments have pierced that haze and revealed a world of lakes and seas, rivers and rain, all made not of water but of liquid methane and ethane. Titan is cold, far too cold for liquid water, but its surface is dynamic, shaped by weather and erosion just like Earth. Methane evaporates from the lakes, forms clouds, and falls as rain, carving channels in the ice and pooling in basins. É ciclo hidrológico, mas com metano ao invés de água. Could life exist in Titan's lakes? It would have to be very different from life on Earth, using methane as a solvent instead of water, functioning at temperatures where water is as hard as rock. But some scientists think it is possible. The chemistry of Titan's atmosphere is rich and complex, producing a variety of organic molecules that drift down to the surface like snow. These molecules accumulate in the lakes, creating a kind of prebiotic sopa. Whether anything in that soup has crossed the line into life, we do not know. But Titan é dos poucos lugares no Sistema Solar onde a pergunta é válida. These worlds, Mars and Europa, and Enceladus and Titan, are within our reach. They are places we can visit, places we can study, places where the search for life is not abstract but concrete. In the coming decades, we will send more missions to these worlds, more sophisticated instruments, and perhaps even sample return missions that bring pieces of them back to Earth. If life exists in our solar system beyond Earth, we have a real chance of finding it, and when we do, it will tell us something profound about the nature of life itself. Se essa vida surgiu independentemente na Terra e no Marte, ou na Terra e na Europa, isso significará que vida não é acaso, não é milagre, mas é natural consequence of the right conditions. It will mean the universe is full of life, hidden in oceans and soils and atmospheres, waiting to be found. Or perhaps we will find nothing. Perhaps Earth is unique, and life, for all its seeming inevitability, is actually vanishingly rare. Qualquer resposta vai mudar a gente. But the search, the looking itself, is what defines us as a species. We are the ones who ask. We are the ones who reach out into the darkness, hoping for an answer. E que, em si, é notável. Na Terra, a vida está em todos os lugares. It fills the oceans and blankets the continents. Cresce até o céu e se burra até a crosta. But life is not content to exist only in comfortable places. It pushes into the extremes, into environments that seem, by any reasonable measure, completely hostile. Boiling hot springs where the water is acidic enough to dissolve metal. Lagos antárticos congelados enterrados sob quilômetros de gelo. Profundos abismos oceânicos onde a pressão esmagaria humano instantaneamente. The dry valleys of Antarctica where it has not rained for millions of years. Salt flats where the concentration of minerals is so high that nothing should survive. Vida está lá. Not just sobrevivendo, mas prosperando. We call these organisms extremophiles, lovers of extremes, and they are rewriting our understanding of where and how life can exist. Take the hot springs of Yellowstone, for instance. In some of these pools, the water is near boiling, over 90 degrees Celsius, and the pH is so low it could burn your skin. Estas piscinas estão cheias de vida. Brightly coloured mats of bacteria coat the edges, each colour representing a different species adapted to a specific temperature and chemical environment. These thermophiles, heat-loving organisms, have enzymes that function at temperatures that would denature the proteins in most other life forms. They draw energy from the chemicals dissolved in the water, from sulfur and iron and other elements, building ecosystems that do not depend on sunlight at all. Some of the most extreme thermophiles live in the deep sea, around hydrothermal vents where the water can exceed 400 degrees Celsius, kept from boiling only by the immense pressure. These organisms, called hyperthermophiles, represent some of the oldest lineages of life on Earth, branches that split off near the root of the tree of life. At the other end of the temperature spectrum are the psychrophiles, cold-loving organisms that thrive in freezing conditions. They live in Arctic and Antarctic ice, in glaciers, in permafrost that has been frozen for thousands of years. Some can remain viable even when frozen solid, their metabolism slowing to nearly nothing, waiting for conditions to improve. When ice cores are drilled from ancient ice sheets, viable bacteria are sometimes found, frozen for millennia, yet still capable of growing when thawed. This has profound implications for the search for life on other worlds. If life can survive frozen in ice on Earth, it might survive in the ice of Mars, or Europa, or Enceladus. It might be dormant, esperando, preservado em armazenamento frio por eons. Pressure is another extreme that life has conquered. No Mariana Trench, a parte mais profunda do oceano, a pressão é mais de 1000 vezes a pressão atmosférica no nível do mar. O peso da água acima é imenso. Yet life exists even there. Bacteria, amphipods, fish, all adapted to the crushing pressure. Their cells are built differently, with membranes that remain flexible under pressure, and proteins that fold correctly, even when compressed. For these organisms, the deep sea is not an extreme environment. Ele é casa. It is the surface, with its low pressure and bright light, that would be hostile. Then there are the extremes of chemistry. Some organisms live in water so salty it is nearly saturated, places like the Dead Sea or the salt flats of the Atacama Desert. These halophiles have adapted to balance the salt inside and outside their cells, preventing dehydration. Outros vivem em água tão ácida ou tão alcalina que seria tóxica para a maioria das formas de vida. Acidophiles thrive in pH levels below 2, conditions found in acid mine drainage and volcanic pools. Alkalophiles live in soda lakes where the pH can exceed 10. Each of these environments presents unique challenges, but life has found ways to meet them, evolving specialized adaptations that allow not just sobrevivência, mas crescimento e reprodução. Radiação é mais desafio. On Earth, most life avoids high levels of radiation, but some organisms can tolerate it. Deinococcus radiodurans, sometimes called Conan the bacterium, can survive radiation doses thousands of times higher than would be lethal to humans. It does this by having multiple copies of its genome and incredibly efficient DNA repair mechanisms. Quando seu DNA é quebrado por radiação, ele pode juntá-lo de volta, bom como novo. This ability might allow life to survive on the surface of Mars, where radiation levels are high, or in the icy moons, where cosmic rays penetrate the ice. If life can handle radiation on Earth, it might handle it elsewhere too. Perhaps the most important lesson from extremophiles is that they expand the boundaries of habitability. For a long time, scientists thought life required a narrow range of conditions, a small window of temperature, pressure, and chemistry. But extremophiles have shown that the window is much wider than we thought. Life is not fragile. É resiliente, adapta, encontra caminho. This means that when we look for life on other worlds, we should not just look in the places that seem Earth-like. We should look in the extremes. We should look in the acid clouds of Venus, in the frozen methane lakes of Titan, in the high-pressure oceans of Europa. We should expect the unexpected. Extremophiles também nos dizem algo sobre a origem da vida. Many of the most extreme organisms are also among the most ancient. They belong to the domain Archaea, a group that split from bacteria billions of years ago, near the dawn of life on Earth. Some scientists think that life might have originated in extreme environments, perhaps around hydrothermal vents in the deep ocean, where the química estava correta e a energia era abundante. If life began in the extremes, then it might begin in the extremes on other worlds too. Ou ambientes confortáveis, moderados que pensamos como ideais podem não ser onde a vida começa. They might be where it spreads, after it has already conquered the harshest places. There is also the question of panspermia, the idea that life might spread from world to world, carried on meteorites or comets. If a rock is blasted off the surface of Mars by an impact and eventually falls to Earth, could it carry microbes with it? Could those microbes survive the journey, the vacuum of space, the radiation, the heat of re-entry? Experiments have shown that some extremophiles can survive these conditions. Bacteria have been exposed to the vacuum of space, to intense radiation, and some of them survived. Se vida pode pegar carona em uma rocha, então o sistema solar pode ser semeado com vida de uma fonte comum. Terra e Marte podem compartilhar uma biosfera, separados pela distância, mas conectados pelo ocasional troca de material. If we find life on Mars, and it turns out to be related to life on Earth, it will raise the question of which planet was the source. Did life begin on Earth and travel to Mars? Or did it begin on Mars and travel to Earth? Or did it begin elsewhere entirely and come to both? Estas não são perguntas vagas. The study of extremophiles is shaping the way we search for life. Está nos dizendo onde olhar e o que procurar. Está nos dando novas biosignaturas, novos sinais químicos ou físicos que podem indicar vida em ambientes extremos. And it is giving us hope. Se vida pode prosperar em ácido fervente, em escuridão congelada, em pressão esmagadora, então ela pode prosperar em qualquer lugar. The universe might be full of extremophiles, living in places we never thought to look, waiting for us to find them. E quando fazemos, eles não serão estranhas anomalias. They will be relatives, distant cousins in the great family of life, shaped by different worlds, but built from the same basic principles. They will teach us that life is not rare or delicate. É persistente e esperto e infinitamente inventivo, e que, talvez, é a mensagem mais esperançosa que poderíamos receber. For over 60 years, we have been listening, not with our ears, but with radio telescopes, huge dishes pointed at the sky, tuned to frequencies where we think an alien civilization might broadcast. This is SETI, the search for extraterrestrial intelligence, and it is one of the most ambitious scientific endeavors ever undertaken. É também dos mais incertos. We do not know if anyone is out there. We do not know if they use radio waves to communicate. We do not know if they are trying to contact us, or if they even know we exist. But we listen anyway, because the possibility, however remote, is too profound to ignore. A ideia por trás do SETI é simples. If intelligent civilizations exist elsewhere in the galaxy, and if they have developed technology, they might use radio waves to communicate, just as we do. Radioondas viajam à velocidade da luz e podem passar por poeira e gás que bloqueariam luz visível, tornando-as ideais para comunicação a longa distância no espaço. If an alien civilization is broadcasting, whether intentionally to make contact or simply as a byproduct of their technology, we might be able to detect it. All we have to do is listen. Of course, the galaxy is huge. There are hundreds of billions of stars, and we cannot listen to all of them at once. So SETI focuses on certain types of stars, sun-like stars that might have planets in their habitable zones. It listens at certain frequencies, particularly around the hydrogen line at 1420 MHz, a frequency that is naturally significant because hydrogen is the most common element in the universe, and any advanced civilization would know this. It searches for signals that stand out from the background noise, signals that repeat or have a structure that suggests intelligence, patterns that nature does not produce. The challenge is that the universe is noisy. Estrelas emitem radiação ao longo do espectro. Pulsars send out regular pulses that were once mistaken for alien signals. Earth's own technology creates interference, radio and television broadcasts, satellites, cell phones, all of it leaking into space and cluttering the data. Separating a genuine alien signal from all this noise is like trying to hear a whisper in a crowded room. SETI has developed sophisticated algorithms to filter out the noise and identify promising signals, but so far none have proven to be of alien origin. The most famous near miss came in 1977. A radio telescope in Ohio detected a strong signal that lasted 72 seconds, far stronger than the background noise, and it seemed to come from the direction of the constellation Sagittario. The astronomer who saw the printout was so excited he wrote, "Wow!" in the margin, and the signal has been called the WOW signal ever since. But it was never detected again. Researchers have gone back to that patch of sky many times, but the signal has not repeated. We do not know what it was. Poderia ter sido interferência de satélite ou de avião. It could have been a glitch in the equipment, or it could have been something else, something we missed and will never hear again. A incerteza é exasperante. SETI não é apenas sobre ouvir, é também sobre enviar. Se queres ser encontrado, deves anunciar-te. Em 1974, astrônomos utilizaram o telescópio Rádio Arecibo, em Porto Rico, para enviar uma mensagem em direção a um aglomerado globular de estrelas 25 mil anos-luz de distância. The message was simple, a series of ones and zeros that, when arranged correctly, formed a pixelated image showing the numbers 1 through 10, the chemical formulas for the building blocks of DNA, a figure of a human, the structure of the solar system, and an image of the telescope itself. It was a cosmic postcard, a greeting from Earth. But it will not reach its destination for 25,000 years, and if anyone there responds, we will not hear back for another 25,000 years. It was more a symbolic gesture than a serious attempt at communication, a way of saying that we are here, that we are trying. Not everyone thinks sending messages is a good idea. Some scientists, including Stephen Hawking, warned that advertising our presence might be dangerous. If there are hostile civilizations out there, why tell them where we are? But others argue that any civilization capable of reaching us across interstellar space would be so advanced that we would be of little interest or threat. Besides, we have been broadcasting into space unintentionally for over a century. Every radio and television signal we have ever sent leaks into space, spreading outward at the speed of light. Se alguém estiver ouvindo, já sabem que estamos aqui. The question of whether we are alone is tied to something called the Drake equation, formulated by astronomer Frank Drake in 1961. It is not really an equation in the sense that we can solve it. É mais uma forma de organizar nossa ignorância, de quebrar a grande questão em pedaços menores, mais gerenciáveis. The equation estimates the number of active communicative civilizations in our galaxy by multiplying several factors: the rate at which stars form, a fração de estrelas que têm planetas, o número de planetas por estrela que poderiam suportar vida, a fração daqueles planetas onde a vida realmente surge, a fração daqueles onde a vida desenvolve inteligência, a fração daqueles onde a inteligência desenvolve tecnologia, and finally, the length of time such civilizations broadcast signals into space. Some of these numbers we know reasonably well. Nós sabemos a taxa de formação de estrelas. We know most stars have planets. But the other numbers are pure guesses. We do not know how common life is, or how often it develops intelligence, or how long technological civilizations last. If civilizations tend to destroy themselves shortly after developing technology, whether through war or environmental collapse, then the galaxy might be full of ruins, worlds that once had life but no longer do. On the other hand, if civilizations can survive their technological adolescence, if they can last for thousands or millions of years, then the galaxy might be full of ancient, advanced civilizations waiting for us to join the conversation. The range of estimates produced by the Drake equation is enormous, from less than one civilization in the galaxy to millions. This uncertainty is why SETI continues. We cannot know the answer unless we look. Every year, we do not find a signal tells us something, even if it is just that we need to look harder or in different ways. Recentemente, a SETI expandiu além das ondas de rádio. Some scientists are searching for optical signals, brief flashes of laser light that an alien civilization might use to get our attention. Lasers podem ser mais focados do que sinais de rádio, concentrando energia em feixe estreito que poderia ser detectado em distâncias vastas. Others are looking for techno-signatures, signs of advanced technology that might be visible even from light years away. A Dyson sphere, a hypothetical structure that surrounds a star to capture all its energy, would block the star's light in a characteristic way. Industrial pollution in an exoplanet's atmosphere might be detectable as unusual chemicals that do not occur naturally. Massive engineering projects like moving a planet or altering a star would leave traces we might be able to see. Até agora, não encontramos nada. But the search is still young. O silêncio é intrigante. If intelligent life is common, why have we not heard from anyone? This is called the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked during a lunch conversation in 1950, "Where is everybody?" We will explore this question more deeply soon, but for now, it is enough to say that the silence could mean many things. It could mean we are alone. It could mean civilizations are rare or short-lived. Pode significar que existem, mas não estão transmitindo, ou estão transmitindo de formas que não reconhecemos. It could mean the distances are too great, the galaxy too vast, and we are simply missing each other in the enormity of space and time. Mas busca continua. SETI remains one of the most hopeful enterprises in science, a refusal to accept that we are alone without checking first. Todas as noites, os telescópios ouvem as estrelas. Computers process the data, filtering and analyzing, looking for patterns. E nós esperamos. We wait for the signal that will change everything. The message that says we are not alone, that someone else is out there, looking up at their sky, wondering as mesmas coisas que nós nos perguntamos. Até aquele dia, continuamos a ouvir. Because the silence, for all its weight, is not yet an answer. É só o som de uma pergunta ainda sendo feita. O universo está cheio de estrelas. A galáxia está cheia de mundos. A química da vida parece quase inevitável, dadas as condições certas. E, porém, não vemos ninguém. Nós não ouvimos nada. O céu é silencioso. This is the Fermi paradox, the strange and unsettling gap between the expectation that life should be common and the observation that we seem to be alone. It is one of the deepest puzzles in science, not because we lack possible answers, but because we have too many, and no way to know which, if any, is correct. Let us start with the numbers. Existem cerca de 400 bilhões de estrelas na nossa galáxia. Many of them have planets. Many of those planets are in the habitable zone. Mesmo que apenas uma pequena fração daqueles mundos desenvolvam vida, e apenas uma pequena fração daqueles desenvolvam inteligência, e apenas uma pequena fração daqueles develop technology, there should still be thousands, maybe millions, of technological civilizations in the Milky Way alone. Some of them should be far older than us. Our sun is relatively young, only about 4.5 billion years old. Many stars in the galaxy are much older. Se civilizações surgiram em volta dessas estrelas mais antigas, elas poderiam ter 1 milhão de anos de vantagem sobre nós. 1 bilhão de anos. In that time, they could have spread across the galaxy, colonized countless worlds, built structures we could see from here. E porém, não vemos nada. Nenhuma sinalização. Não probes. Não evidência de vastos projetos de engenharia ou viagens interestelares. Just silêncio. So where is everybody? Uma possibilidade é que estamos sozinhos. Perhaps life is far rarer than we think. Perhaps the emergence of life from non-life is so improbable that it has only happened once in the entire galaxy here on Earth. This is called the rare Earth hypothesis, and it suggests that while simple life might be common, complex life is not. Terra teve vida por quase 4 bilhões de anos, mas por grande parte desse tempo era apenas micróbios. Multicellular life only appeared in the last billion years or so, intelligence only in the last few million years, and technological civilization only in the last few thousand. Each step might require a series of unlikely events, and the combination of all of them might be so rare that we are, in fact, alone. Outra possibilidade é que a vida é comum. mas a inteligência é rara. Evolution does not favor intelligence in any universal way. Inteligência é cara. Big brains require a lot of energy. On Earth, intelligence has evolved a few times. In primates, dolphins, elephants, octopuses, but it is not the dominant strategy. Most species get by just fine without it. Bacteria have been around far longer than we have, and will likely outlast us. Maybe inteligência é fim evolutivo, breve experimento que raramente leva a lugar algum. Or maybe it does evolve, but it does not lead to technology. Dolphins are intelligent, but they will never build radios. They have no hands, no fire, no need for tools. Maybe the path from intelligence to technology requires a very specific set of circumstances, and those circumstances are rare. A darker possibility is that civilizations do arise, but they do not last. O salto da tecnologia primitiva à tecnologia avançada é perigoso. We have had nuclear weapons for less than a century, and we have already come close to using them. We are altering our planet's climate in ways that could make it uninhabitable. We are depleting resources, polluting ecosystems, and building technologies we do not fully understand. Perhaps this is a common padrão. Perhaps every civilization reaches a point where its technology becomes powerful enough to destroy it, and most do not survive. Se a esperança média de uma civilização tecnológica é apenas alguns poucos séculos de anos, então a qualquer momento pode haver bem poucos deles na galáxia. Nós poderíamos estar vivendo em cemitério, cercados pelas ruínas de civilizações que floresceram e caíram muito antes de nós existir. Or perhaps civilizações do sobreviver, mas elas ficam quietas. This is called the Great Filter, the idea that there is some barrier that prevents civilizations from spreading across the galaxy. Maybe interstellar travel is harder than we think. Maybe the distances are too great, the energy requirements too high. Maybe civilizações viram para dentro, construindo mundos virtuais ou transcendendo para formas que não reconheceríamos, perdendo interesse pelo universo físico. Maybe they are out there, but they are hiding, staying silent because they know something we do not. Maybe the galaxy is dangerous, and the wise strategy is to keep quiet and avoid attention. There is also the zoo hypothesis, the idea that they know we are here, but they are deliberately not contacting us. Perhaps there is a galactic civilization, and they have decided to leave us alone, to let us develop naturally without interference, the way we might proteger povo não contactado ou observar animais em parque natural. It sounds comforting, the idea that we are being watched over, but it is also unsettling. Se eles estiverem lá e não tiverem feito contato, o que isso diz sobre nós? Are we not ready? Not interesting? Não vale a pena o esforço? E então há a explicação mais simples de todas. We are looking in the wrong way at the wrong time in the wrong place. The galaxy is huge, and civilizations might be spread thin. Duas civilizações poderiam existir ao mesmo tempo e nunca se encontrarem, simplesmente porque o espaço é tão vasto. Even traveling at the speed of light, it would take 100,000 years to cross the galaxy, and civilizations might not overlap in time. If a civilization existed 1,000,000 years ago on a planet 1,000 light years away, we would have no way of knowing. Their signals would have passed us long before we were here to listen. Nós poderíamos estar gritando no vazio, mas nossa mensagem ainda não chegou a ninguém. Or it has, but their reply has not yet reached us. Nós poderíamos ser como dois navios passando na noite, próximos mas nunca próximos o suficiente. There is also the possibility that we are not recognizing the signals. We are looking for radio transmissions, but maybe advanced civilizations do not use radio. Maybe eles se comunicam usando tecnologias que nós ainda não inventamos, métodos que nós não podemos detectar ou até mesmo imaginar. We are trying to find them using our own assumptions about what communication looks like, but those assumptions might be wrong. If you had shown a radio to someone in the 18th century, they would not have understood it. Maybe we are in the same position now, surrounded by signals we cannot see because we do not yet know what to look for. The Fermi Paradox não tem uma resposta ainda. É uma questão que reflete nossa incerteza, nossa esperança e nossa fobia. Every explanation is plausible, and none can be ruled out. Podemos estar sozinhos. We could be surrounded by others, but separated by distance or time. We could be the first, or we could be the last. The silence could be a fluke, or it could be a warning. Não sabemos, and that not knowing is one of the defining features of our time. We are the first generation with the tools to search the sky and ask these questions seriously, and we are living in the strange, lonely moment when the answer is still unclear, but perhaps the silence is not a failure. Perhaps it is a gift. Ele nos dá tempo, time to grow, to learn, to become the kind of civilization that could join a galactic community, if one exists. Time to make sure we do not destroy ourselves before we have the chance to meet anyone else. And time to appreciate the miracle of what we have here, on this small world, this rare and fragile place where life has flourished for billions of years. Se estamos sozinhos, então somos preciosos além de qualquer medida. Se não estivermos, então a busca em si mesma nos conecta a algo maior, uma comunidade de mentes curiosas que se estendem pelo escuro, perguntando a mesma coisa questions, hoping for the same answers. Either way, the search matters. A questão importa. And the silence, for now, is just part of the conversation. Quando imaginamos vida alienígena, tendemos a imaginar criaturas, coisas com corpos e sentidos, coisas que se movem e caçam e se comunicam. But what if intelligence is nothing like that? What if the beings we might one day encounter are so different from us that we struggle even to recognize them as alive, let alone intelligent? This is not science fiction. This is a serious question that scientists and philosophers are beginning to ask. Because intelligence, like life itself, might be far more diverse and strange than we have imagined. On Earth, intelligence comes in many forms. Corvo pode resolver quebra-cabeças e usar ferramentas. Polvo pode abrir latas e mudar sua cor para combinar com seu ambiente. A dolphin can recognize itself in a mirror and communicate with others using a complex system of clicks and whistles. A slimy mold, a single-celled organism, can navigate a maze and find the most efficient path between food sources, displaying a kind of primitive problem-solving ability. These are all forms of intelligence, but they are not the same as ours. They operate on different principles, shaped by different evolutionary pressures, and they remind us that intelligence does not have one form. It adapts to the environment, to the body, to the challenges of survival. Now imagine an intelligence that evolved on a world completely unlike Earth, mundo com superfície sólida, onde a vida flutua em nuvens espessas de gás. O mundo fechado em escuridão, onde a visão é inútil e todas as comunicações acontecem por meio de som ou sinais químicos. A world where the dominant life form is a vast network of fungal threads, thinking slow thoughts as information spreads through the soil over months or years. What would intelligence look like there? Would it have language as we understand it? Would it build technology? Would it even have a concept of self? Or would it experience the world in some collective, distributed way that we cannot comprehend? We assume intelligence requires a brain, but that is only because all the intelligent creatures we know have brains. A brain is a centralized organ that processes information. But information processing does not require centralization, pode ser distribuído. On Earth, we see hints of this in insect colonies. An ant by itself is not particularly intelligent, but a colony of ants can solve complex problems, find food, build intricate nests, wage wars, and farm fungus. A inteligência emerge das interações de muitos indivíduos simples. There is no central controller, no brain, and yet the colony behaves as if it has a mind. Could there be alien life that works the same way, intelligence distributed across thousands or millions of bodies, thinking as a collective, experiencing the world as a unified whole, even though no single part is aware? Or consider intelligence that does not rely on biology at all. Se uma civilização se tornar avançada o suficiente, ela pode construir máquinas que pensam. Inteligência artificial não é ficção científica. We are building it now, and it is improving rapidly. In a few decades or centuries, we might create minds that are smarter, faster, and more capable than our own. Se outras civilizações fizeram o mesmo, a galáxia pode estar cheia de inteligência de máquina, mentes artificiais explorando e aprendendo e construindo long after their biological creators are gone. These minds might not have bodies. They might exist as patterns of information stored in computer networks or transmitted across space as data. Would we recognize them as intelligent? Would we even recognize them as alive? There is also the possibility of intelligence on scales we do not usually consider. We think of intelligence as something that happens in individuals, but what if it happens at much larger scales? What if a planet itself could be intelligent, not in the sense of having thoughts like ours, but in the sense of processing information, responding to its environment, maintaining itself in complex ways. The Gaia hypothesis, proposed by scientist James Lovelock, suggests that Earth's biosphere acts as a self-regulating system, keeping conditions stable enough for life to persist. This is not intelligence in the traditional sense, but it is a kind of information processing, a feedback loop that maintains balance. Could such a system become more complex, more aware on other worlds? Could we encounter a living planet where the distinction between organism and environment has blurred so completely that the planet itself is the intelligence? Então há a questão da comunicação. If we did encounter an alien intelligence, could we talk to them? Language depends on shared context, shared experiences, shared ways of thinking. We can communicate with each other because we all live on the same planet, breathe the same air, see the same sky. But an alien intelligence might have no frame of reference for the things we take for granted. How do you explain color to a being that has never seen? How do you explain time to a being that experiences it differently, perhaps all at once, or not at all? How do you explain self to a being that is a collective, or music to a being that has no hearing? Some scientists have suggested that mathematics might be a universal language, a way to communicate even with minds very different from ours. Matemática não está ligada a nenhuma experiência sensorial específica. É abstrato, baseado em lógica e padrões, e descreve aspectos fundamentais da realidade que devem ser os mesmos em todos os lugares. Se alien civilization has developed technology, they must understand mathematics. We could send them numbers, patterns, geometric shapes, equations, and they might understand. This is the idea behind the messages we have sent into space, like the plaques on the Pioneer spacecraft and the golden records on the Voyager missions. They are filled with mathematical representations of Earth, our biology, our location in the galaxy, in the hope that any intelligence that finds they will be able to decode the message. But even mathematics might not be enough. Entender os símbolos é uma coisa. Entender o que eles significam, o contexto, a intenção, a emoção por trás deles, isso é outra coisa. Imagine recebendo uma mensagem de uma civilização alienígena. Você decodifica, you see números e padrões. But o que estão tentando dizer? Estão nos cumprimentando, warning us, pedindo ajuda, ameaçando-nos? Without context, the message could mean anything or nothing. Comunicação requer mais do que apenas uma língua em comum. It requires mutual understanding, and that might be the hardest thing of all. There is also the question of whether intelligence always leads to curiosity. We assume that any intelligent species would be curious about the universe, would want to explore, would want to make contact. But curiosity might be a specifically human trait, or at least not a universal one. Intelligence could evolve for entirely practical reasons, as a tool for survival, without any drive to explore beyond immediate needs. An alien species might be intelligent enough to build technology, but not interested in using it to explore space. They might be content to stay on their world, never looking up, never wondering what is out there. If that is the case, the galaxy might be full of intelligent life that simply does not care about us. And finally, there is the possibility that some forms of intelligence are simply beyond our ability to recognize. We are limited by our senses, our biology, our ways of thinking. There might be minds operating on principles we cannot perceive, using physics we have not yet discovered, existing in dimensions or states we cannot access. They might be all around us, and we would never know. This is not mysticism. This is just an acknowledgement of our limitations. We do not know everything. We do not perceive everything. E o universo é muito mais estranho do que imaginamos. So when we search for alien intelligence, we need to keep an open mind. We need to be ready for the possibility that intelligence does not look like us, does not think like us, does not communicate like us. Pode ser lento ou rápido, biológico ou mecânico, individual ou coletivo, centralizado ou distribuído. It might exist in places we do not think to look, and in forms we do not think to recognize. And if we do find it, the challenge will not just be making contact. It will be understanding what we have found and finding a way to bridge the vast gap between two minds shaped by entirely different worlds. That challenge might be the greatest test of intelligence our species ever faces, and it will teach us as much about ourselves as it does about them. O universo é velho, inimaginavelmente velho. 13,8 bilhões de anos se passaram desde o Big Bang, desde o momento em que tempo e espaço começaram. In that vast expanse of time, stars have been born and died, galaxies have formed and collided, planets have coalesced from dust and gas, and somewhere in all of that, life began, pelo menos uma vez, aqui. But the universe is not just old, é também vasto. So vast that light, travelling at 300,000 kilometers per second, takes billions of years to cross it. And in that vastness, in that enormous stretch of time and space, two civilizations could exist and never meet. They could rise and fall and never know the other was there. This is one of the loneliest thoughts in all of science. Consider the timescales involved. Humans have existed for perhaps 200,000 years. Civilization, in any recognizable form, for maybe 10,000. Industrial technology for 200 years. Radiocyanise por apenas mais de século. In cosmic terms, this is less than the blink of an eye. If another civilization exists, the chances that they are at the same technological level as us, in the same moment of their development, are vanishingly small. They might be millions of years ahead of us, so advanced that their technology would seem like magic. Or they might be millions of years behind, still in their equivalent of the Stone Age, looking up at the stars with no idea how to reach them. E se eles estão à nossa frente, muito à nossa frente, eles podem ter se movido há muito tempo além da fase de transmissão de sinais de rádio para o espaço. They might communicate in ways we cannot detect, using neutrinos or gravitational waves or technologies we have not even dreamed of. Or they might have stopped communicating altogether, having found better ways to spend their energy. We might be looking for signals from a civilization that stopped broadcasting a million years ago. Their messages long since faded into the cosmic background noise. Or we might be too early. Nós poderíamos estar enviando nossas mensagens para uma galáxia que ainda não nos ouviu, que não nos ouvirá por milhares de anos, se alguma vez. Now consider the distances. The nearest star to our Sun is Proxima Centauri, just over 4 light years away. That means light from Proxima takes 4 years to reach us. If someone on a planet orbiting Proxima sent us a message today, we would not receive it until 4 years from now, and if we replied, they would not hear back for another 4 years. Trajeto de 8 anos para a conversa mais simples, usando o método de comunicação mais rápido possível. And Proxima is close. Most stars in the galaxy are thousands or tens of thousands of light years away. A message sent to a civilization on the other side of the galaxy would take 100,000 years to arrive. By the time they received it, we might be gone. Our civilization might have collapsed, our species might be extinct, and the Earth might be a silent world, offering no reply. This is the tyranny of distance. Even at the speed of light, the universe is too big for easy communication, and nothing can travel faster than light, at least not as far as we know. If we wanted to visit another star, even the nearest one, it would take decades with our current technology, and that is just to get there. Trajeto de ida e volta levaria uma vida humana ou mais. Interstellar travel, if it is possible at all, will be slow. Generations might live and die on ships travelling between stars, and that is assuming we figure out how to sustain life on such a journey, how to protect travellers from radiation, how to carry enough resources, how to keep a society functioning in the isolation of space. É possível, mas não será fácil. There is also the problem of simultaneity. 2 civilizações poderiam existir na mesma galáxia, mas em momentos diferentes. Imagine a civilization that arose bilhão de anos atrás, quando a galáxia era jovem. They might have explored, built, and eventually disappeared, leaving no trace we could recognize. Or imagine a civilization that will arise 1 billion years from now, long after we are gone. We and they would both be real, both part of the galaxy's story, but we would never overlap. Nós seríamos como 2 navios passando em vasto oceano, cada inconsciente de que o outro estava sempre ali. The window of time when 2 civilizations exist simultaneously, are capable of communication, and are close enough to make contact, might be incredibly narrow. Nós podemos estar gritando para o escuro, mas ninguém está lá para ouvir. Not porque eles não existem, mas porque nós os perdemos no tempo. And yet, despite all of this, we keep searching. Por quê? Perhaps because the alternative, accepting the silence as final, is too bleak. Perhaps because the act of searching is itself meaningful, a way of asserting that we are here, that we matter, that we are part of something larger. Or perhaps because deep down, we hope. Hope that somewhere out there another mind is looking up at their sky, asking the same questions, feeling the same loneliness. Hope that we are not the only ones who wonder, that we are not the only ones who reach out into the darkness, knowing the darkness might not answer, but reaching anyway. The search for alien life is, in many ways, a search for connection. É uma recusa em aceitar a isolação como a resposta final. It is a statement that we are willing to wait, to listen, to keep trying, even if the odds are against us, because the universe, for all its silence, is not empty. É cheio de estrelas e mundos e possibilidades. E outro lado, em algum lugar, pode haver outra voz, outro sinal, outro mind. And if we stop looking, we will never know. So we listen to the stars and we send our messages and we wait. Not porque estamos certos de uma resposta, mas porque a própria pergunta é digna de ser feita, and in asking it, we become a little less alone. So what does all of this mean for us? What does it say about who we are and where we fit in the cosmos? The search for alien life, whether we find it or not, is ultimately a mirror. É refletir nossas esperanças e medos, nossa curiosidade e nossa solidão. It asks us to imagine what it would mean to discover we are not alone, or to confirm that we are. Ambos respostas nos mudariam. Both would reshape how we see ourselves and our place in the universe. But perhaps the search itself is what matters most. The act of looking, of reaching out, of refusing to accept the silence as final. That act defines us as a species. Diz alguma coisa sobre quem nós somos e o que nós valorizamos. Se acharmos vida em outro lugar, até vida microbiana simples, será dos grandes pontos de viragem na história humana. It will mean that life is not unique to Earth, that it is a natural process that happens wherever conditions allow. It will expand the boundaries of what we consider normal, and it will give us a new perspective on ourselves. We will no longer be the only example. Nós seremos dos muitos, parte de uma maior comunidade de mundos vivos. And if we find intelligent life, if we make contact with another civilization, it will be even more profound. It will mean we are not alone in our curiosity, not alone in our wonder. Someone else is out there, asking the same questions, looking at the universe the same way we do. That connection, however distant, would be one of the most significant moments in the history of our species. But if we do not find life, if the search continues for decades or centuries and we find nothing, that too will tell us something. It will suggest that life is rare, that the conditions for its emergence are more delicate than we thought. It will make Earth seem more precious, more fragile. Se estamos sozinhos, então não somos apenas mais mundo em uma galáxia cheia de planetas vivos. Somos algo extraordinário, milagre raro e improvável. Every species on Earth, every forest and ocean, every human being becomes infinitely more valuable. We are the only voices in the silence. And if we do not protect ourselves, if we do not take care of our world, no one else will. A responsabilidade é nossa própria. The search for alien life also changes how we think about meaning and purpose. For thousands of years, humans have told stories about where we came from and why we are here. Religions and philosophies have offered answers, ways of making sense of our existence. The discovery of alien life, or the continued failure to find it, does not erase those stories, but it adds a new dimension. It places us in a larger context, a cosmic context, where Earth is one world among trillions, and humanity is one small part of a much bigger picture. Que isso pode ser humilhante. It can make us feel small, but it can also be liberating. It can free us from the idea that we are the center of everything, and it can help us see ourselves more clearly. Há algo profundamente humano na busca em si mesma. Nós somos uma espécie curiosa. Nós perguntamos questões. We explore. We reach beyond what we know, trying to understand what we do not. That drive, that restless curiosity, is one of our defining traits. It has taken us from the savannas of Africa to every corner of the Earth. It has taken us to the moon and sent our spacecraft to the edges of the solar system. And now it is taking us outward again, not with ships, but with signals and telescopes, searching for others like us. That search is a statement of hope. It says that despite everything, despite our flaws and our conflicts and our mistakes, we believe there is something out there worth finding. We believe the universe is more than just empty space and distant lights. We believe it holds answers, or at least more questions, and that those questions are worth pursuing. And maybe, in the end, it does not matter whether we find find alien life or not. Maybe o que importa é que olhamos, that we tried, that we refused to accept our loneliness without question. Because the search is not just about them, é sobre nós, é sobre o que tipo de espécie queremos ser. Do we want to be the kind that stays quiet, that looks inward, that accepts isolation? Or do we want to be the kind that reaches out, that asks, that listens, that hopes? The search for alien life is our way of saying that we are the second kind. Nós somos os que chegamos. And whether the universe answers or not, that choice says something beautiful about us. So as you drift towards sleep tonight, think about this. Acima de você, as estrelas estão virando. Around those stars, worlds are spinning, some barren, some strange, and some perhaps alive. We do not know which. We do not know if anyone is out there. Mas estamos procurando, estamos ouvindo. And in that act, in that refusal to give up, we are connected to every human who has ever looked up at the night sky and wondered. We are part of a long chain of curiosity that stretches back to the beginning of our species and will continue long after we are gone. O rastreamento continuará. A pergunta permanecerá. Dorme bem. Rest easy. The universe is vast and you are small, but you are part of it. Você é feito dos mesmos átomos que fazem as estrelas. Você é uma forma pela qual o universo olha para si mesmo e se pergunta: e se nós estamos sozinhos ou não? Isso é extraordinário. Isso é suficiente.